Okay, so in this video, we're gonna create your first Niagara particle simulation. So we can open our VFX folder, right click, and you can either click Niagara System, or you can go under Effects and here select Niagara System. So I'll just pick this one. Now you have a few options here. Usually we will create just a completely empty system. That's how I like to start. Or we can create a new system from a template. So I just want you to know that the templates are here. And so here you have all the available templates for the 2D simulations, the 2D liquids, all of the 3D gas templates. So here's like a shockwave, some basic fire, a simple explosion, some colored smoke. So these are good to click through and also be aware that they are here. But of course, you also want to be able to set these up from scratch. So that's what we're gonna do together, is just make it completely from scratch. So I'll just go back and create an empty system, finish. Let's call it ns underscore particles, enter, double click. And by default, this will open in a brand new window, but I would prefer for it to open like a new tab in my web browser and just automatically get docked over here. So I'll just close it and we can go under edit, editor preferences, and this asset editor open location, you can just say main window. Close that, and now when you double click, it will automatically open as a new tab up here. All right, so inside of Niagara, you have your viewport, you have the main system overview with all of your notes, and then you have the settings on the right-hand side. You also have your timeline. Now, if I hit play, there's nothing because we don't have an emitter. So we're gonna create a new emitter by right-clicking and say add emitter, or you can just hit E. Now again, you're presented with some templates that you can use, but we will just use an empty template. That's the best way to learn. And right away, let's rename it. So F2, and I'll just call it emitter underscore particles. Now I like to have my particles against a black background. So what we can do is just go under window, preview scene settings, and we can uncheck show environment to get just a solid color background. And I'll actually change the color to pure black, say okay. So the emitter is organized in a stack, meaning everything is calculated from top to bottom. You have several different groups, and inside of those groups, you have the individual modules. Now, if I go into my details panel over here, if I just select the emitter as a whole, I get all of the settings listed for the entire emitter, or I can just click on the individual modules or the groups to get all the different settings in just that group or just that module, right? So initialize particle module, all the settings are here. So the best way for you to see how this works is just to create some particles. So I actually just click on emitter update on this little plus icon, and I know that I want to spawn some new particles. So I just type spawn. Basically throughout the course, we're only gonna use one of two things, either spawn burst instantaneous, which is a burst of particles that only happens once, and that's great for something like an explosion, or a spawn rate, meaning you continuously get new particles being born over time. So I'll just click spawn rate, and I'm spawning 0 particles. So I'll just set this to 500. And right now what's happening is the particles are being born right on top of each other. So it looks like there's just one particle. And I would actually like these particles to be a bit smaller. So I'll go into my particle spawn group and click on the initialize particle module. And this is where I set what the particle should look like when it is initially born. So when the particle is born, I want their lifetime to be maybe 3 seconds. And for the size of the particles, I can set this to uniform and give them a size of maybe 3. So now I have some much smaller particles, but they're still being born right on top of each other. So what I would like to do is give them some initial speed and spread them around. So again, under particle spawn, I'll click on the plus sign, and I know I want to give them some velocity. So as soon as I add velocity, it's giving me a warning because a velocity is a force, and Niagara needs to have the solve forces and velocity module in order for the forces to work. So it's basically telling me, hey, you don't have this module there, so it's not gonna work. So I can just click fix issue, and you can see here under particle update, it added the solve forces and velocity module for me. So now the warning is gone and my velocity is working properly, and all of my particles are given the velocity when they're initially born, right? So this is the main difference between particle spawn and particle update. Particle spawn means what happens to the particles when they're initially born. So when the particle is born, it's being given a lifetime, it's being given a size, and it's being given some initial velocity. Particle update is what happens to the particles over the course of their lifetime. So for example, I can make the particles get smaller over time, or I can make them be affected by wind over time. So that's what would happen in the particle update group. In the particle spawn group, again, I'm only choosing what attributes the particles have when they're initially born. So we can go into the add velocity module, and you can see that we have red, green, and blue field, right? So this is X, Y, Z. And if you're not sure which one is which, you have the colors and the gizmo right here. So X is red, Y is green, Z is blue. So if I wanted the particles to go left or right, I can set the Z to 0 and the X to 50, and now they're gonna go left. Minus 50 would be right. Same on the Y-axis. 50 would be sort of forward in our case. Minus 50 would be toward the camera, but I just want them to go up. So I'll just set the velocity to be, let's say 100 on the Z-axis. But right now it's very linear. It's just creating a straight line. So I'll just set the velocity mode to in cone. So it's creating this cone shape. Again, I want them to go up. So I'll just set the x-axis to 0 and the z-axis to 1. I can increase their velocity speed to maybe 100, and I can change the cone angle. So how much they spread out in that cone. I can make it a very narrow cone. So this is good for something like a flamethrower, or I can make it a much wider cone. So I'll just do maybe 50 degrees. Let's save our system, go back into our level, and we can drag the Niagara system into the scene. And here we go, our particles are already being displayed in the scene. You can just hit G to hide the outlines. And here you go. So what I would like to do is for these particles to be affected by gravity and collide with the floor. So I'm gonna go into the particle update, right? The update is what happens to the particles over the course of their lifetime, and I need them to be affected by gravity continuously throughout their life. So under particle update, I'll just click on the plus sign and just type in gravity and add the gravity force. Now by default, this is real world gravity, which is pretty strong. So I'll just set it to minus 500. And we need to add collisions. So again, I need them to collide continuously over the course of their life. So in my particle update group, I want to add the collision module. And that's all you need to do for it to work. You can just, again, save, go back into the level. And here you have your particles already colliding with the floor. We can move it higher up. And here you go. So they're bouncing a bit too much. So in our collision settings, we can lower the restitution. Restitution basically means bounce. So I can just set it to 0.1, and I can increase the friction of the particles with the floor. So I'll just set that to 0.5. And I would also like them to shoot up higher. So I'll go back to my velocity module over here and set the velocity speed to maybe 250. So they actually shoot up a little bit, sort of creating like a fountain. Again, save and go back. And here we go. So the particles are nicely colliding with the floor. Now, one more thing that I'd like to show you is how to scale them down over time. So they actually get small and disappear before they die. So again, particle update, plus sign, size category here. And I want to select scale sprite size because that's what these particles are. They're actually sprites. That's why they are being rendered with the sprite renderer. So you're going to get this curve. Now, the way this curve works is, the way to think of it is in percentages. So 0 is 0% and 1 is 100% of the lifetime of the particle. So even though the particle is alive for 3 seconds, even if I change this to 5 seconds, the curve here still goes from 0 to 1, right? Because it's the normalized age. That's what it's called. It's the normalized age, meaning it's the age of the particle from 0% to 100%. So 1 in this case will always be the end of the life of the particle, and 0 is the beginning of the life of the particle. So I'll just set the lifetime again to 3. And so right now what's happening is the particles start small and then they get big over time. But I actually want the opposite. So I'll just click on this curve template over here, the linear ramp down. And you can click on this zoom to fit all keys so you can see the keys, right? So right now what's happening is the particle is the full size on frame 0, and it's the minimum size or nothing at the end of its life. So if I go back to my level, you can see that's exactly what's happening over here. The particles start big and then they gradually get small until they disappear. Now, what if I wanted them to start invisible, get big, and then end invisible? Well, I can grab this first point and just set it to 0. So now there's nothing being seen at all. And I can right click, add a key in the middle. So in the middle of the lifetime of the particle, which is 0.5 on the graph, I can set this to 1, right? So the particles are born invisible, then they reach their full size in the middle of their life, and then by the time they die, they're invisible again. And I can smooth these keyframes out, so I can right click and just make it auto, which means smooth. I can do the same thing for this one, and I can do the same thing for this one. And so now if I go back into my scene, you can see that's exactly what's happening. They begin invisible, they get big, and then they die invisible again, following this curve. Now, if any of this is confusing for you right now, don't worry about it at all. This is a lot to take in all at once, right? So we're gonna go over all of this over and over again as we set up all of the different particle systems throughout this course. So this is just an introduction where really the main thing that I want you to take away from this is that you have some kind of an emitter. The emitter is being calculated in a stack from top to bottom. So we give birth to some particles with the spawn rate. We set the initial attributes for the particles when they're born under the particle spawn group. So when the particle is born, it's given a lifetime and it's given a size, and it's given that initial velocity, which is making it shoot up. And then we move into the particle update group, where we're changing the behavior of the particles over the course of their life. So we are scaling the particles over the course of their life, we're adding gravity to them, and we're adding collisions to them. And then finally, we are rendering them under the render group with the sprite renderer, right? So that's how it goes from top to bottom. And as far as this system node goes, this is just like a global setting, which will affect all of your different emitters. So you can have many emitters here, but you can control sort of the global settings with this blue node for the whole system. So I'm gonna save that. Then you can go over here, File, and just save all. So this is your first Niagara particle simulation with some collisions and some size changing over life, some velocity. So you can just, freely move this around. And in the next video, we're going to start introducing the volumetric fluids into the mix.